Hi friends, welcome back. I hope you all are doing well right now. I hope you guys are enjoying all of the videos that we've been putting out for you guys. I have made another video for you. Today we're going to be talking about potential and kinetic energy again, but we're going to take it just a little step further today, okay? So let's review what we do know about potential and kinetic energy. We know that energy can be classified into two types. We have potential and kinetic. We know potential energy is an object's stored energy. And we know kinetic energy is energy of motion. So here we have an example of a person that's jumping into the water. We know that way up here, he's higher above the water. We know that he has potential energy. And then once this person jumps, that potential energy which is stored is then converted to kinetic energy of motion. And then again, we have the roller coaster that I know you guys are really familiar with. At the top of this roller coaster, we have potential energy. And then as this cart begins to descend, let me get my pointer so you guys can see. And then as this cart begins to descend, we know that that potential energy is converted to kinetic. And here we have equal parts of potential and kinetic. And then once the cart's at the bottom of the hill, we only have kinetic energy. So potential and kinetic energy, we know that potential energy depends on an object's mass, height, and gravity. So the higher the object is positioned, the more potential energy it has. So the higher up something is, the more potential energy, and the greater the effect that gravity will be. We know gravity is what pulls objects down to Earth. So as this object is free falling back to Earth, there's going to be more effects from gravity pulling back down on it. And we also know the more mass an object possesses, the more potential energy that it has. So more mass, there's more potential energy to be released or to be converted to kinetic energy. Kinetic energy, we know, depends upon mass and speed. So the more mass that an object has, the more kinetic energy it has. We know the more speed that an object has, the more kinetic energy it has as well. So if something has more mass on the inside, then that means that the object's going to have more kinetic energy because there's more mass there. If an object has less mass, then there's going to be less kinetic energy. We can further classify our kinetic energy into two groups, and these are going to be new for you guys. So translational kinetic and rotational kinetic. And they're super simple, so don't get freaked out, okay? So transitional kinetic energy is just motion in a straight line. So motion is when something is moving, and when it's moving in a straight line, then that's going to be known as translational kinetic. So here I have an example of a ball on top of a hill, and I've made kind of a little path right here with this blue line. So as this ball travels down the hill, it's traveling down a straight line essentially, okay? So we're going to look at this angle right here. And this ball is going to travel downhill in a straight line, which is known as translational kinetic energy. Now, rotational kinetic energy is just spinning motion. So if I was to take this ball, and we know that this ball is going to rotate in a circular motion, so it's spinning or it's rotating, then that's going to be known as rotational kinetic energy. So imagine taking like a can of soda or a bottle of soda, putting it on top of a hill, and then watching it roll down. We know that it's going to turn and it's going to spin. So that is our rotational kinetic energy as it spins all the way to the bottom. Okay, so we're going to change gears for just a moment here. We're going to talk about acceleration. So we know that acceleration is change in speed or direction. So it's a change. So anytime we're traveling in a car, for instance, and our speed deaccelerates from 50 miles an hour to 30 miles an hour, then that's acceleration because there was a change in speed. Or if you're traveling in a car and your car's going straight and then it makes a right-hand turn, then we know that there was a change in the acceleration because the direction changed as well. So let's look at speed. We know that speed is we can calculate speed by dividing our distance by our time. So for example, if I have a car, let's say that this car here in the picture, and they're traveling 10 meters in 5 seconds, then 10 divided by 5 is 2. So then our speed will be 2 meters per second. So then that means that this car is traveling 2 meters every second. Okay? This 2 meters per second is the same thing as a rate. Okay? Our meters per second here is the rate. So in order to calculate speed, we're going to divide our distance by time. That gives us our speed. And then our rate is going to be what we're measuring. We're measuring meters by seconds. A lot of times we're more familiar with our miles per hour here in America, but remember that all over the world they use different rates than what we do here. We have meters per second, kilometers per hour, but here we're just working with meters per second in this example. So let's talk about inertia for a moment. Inertia is an object's resistance to any change in motion, including a change in direction. So, for instance, we have this soccer player kicking the soccer ball. So, we know that inertia is involved here because there was a change in motion, okay? The soccer ball was probably just still on the ground, and then the soccer player ran up and kicked the ball, which changed the direction and the motion of the ball. Okay, so the object's resistance to change is known as the inertia. So we can relate this back to Newton's first law of motion, which states that an object will stay at rest and an object in motion will stay in motion unless acted upon by an unbalanced force. So remember whenever we talked about the soccer ball, whenever we were in class together, that if this soccer player was to kick this ball, then this ball would just keep going and going and going and going forever until an unbalanced force acted upon that ball. Okay? So what's going to act upon that ball? Well, more than likely in this situation, it's going to be another soccer player. Another player is going to run up and stop the ball with his foot, or maybe he's going to headbutt it with his head. That is an unbalanced force. Then that's going to make the ball stop, okay? Alright, so now what I would like to challenge you guys to, I want you to think about this question for just a moment. Will all rolling objects accelerate down the ramp at the same rate, regardless of mass or diameter? So remember that diameter is the amount, whenever we have a circle, it's one edge to the other, okay? So that's our diameter. So your challenge is to build a ramp with a 10 or a 20-degree angle. So it doesn't have to be perfect, just something kind of like what I have here. This down here, this angle here is probably going to be around like a 20 or 30-degree angle, I would say. So just build something kind of similar to this. It doesn't have to be hard. You can stack books on top of each other. Just whatever you have laying around the house to build just a small ramp. And then I would like for you guys to get 2 cans. One can that's full and one can that's empty. Maybe like a soda can or just a can that you guys have in your pantries. And I want you guys to make some observations. Remember for our observations that's going to be anything that we can see, touch, hear, smell, or taste. And we're probably not going to have taste in this situation, so just whatever you guys can see, touch, hear, or smell, make sure you write down those observations for me. And I want you guys to hold both cans at the top of the ramp, side by side. At the top up here, side by side, your one that's full and the one that's empty. And then you're just going to let them go and watch them roll down your ramp, okay? And now you're going to answer this question. Which can do you think will make it to the bottom first, and why? So remember the inertia that we just talked about, an object's resistance to change. Remember acceleration, which is a change in an object's direction or speed. And remember what our rotational and transitional kinetic energy are. And then when you guys are finished with this challenge, there will be a small quiz for you guys to do at the end. It should be included in your packet. Remember, you can go back and review this video as many times as you need to. You can pause the video if you need, go back and rewatch the certain parts if you need to as well. Okay? Hope you guys have fun. I miss you, and hopefully we'll see you all soon.